Your question 11 for grade 10 typically is about your electric circuits. So consider the circuit diagram below. Now, by looking at it, you can see it has a parallel form right there. Okay, let me just go and mark it accordingly. Let me mark it up. So as it moves from positive, it has a normal series. It's a normal series until it gets here where it's divided into a parallel form. So this is your conventional, this is your electrons, right? So, and the switch is open here. So what you need to answer firstly is these questions. It says write down the reading on the following: a voltmeter V1. So we have our 24 volts there. So voltmeter V1 is 24 volts. After showing you this, I'll just quickly go to my notes where you can check your voltmeters, right? Your volt readings. So V1, so let's say you had a volt reading here of something. It would be equals to the volt reading here and equals to the volt reading there. So in a series, however, you will have to add the 2 volts, right? Especially in an instance where you have your resistance. So you go Vs is equals to V1 plus V2. Remember that. So now that we've answered that question, let's look at the next question in line. So for the next question, it's B. It says write down the reading on A1. Since the switch is open, it will be 0 amps, right? You need to write, don't just write 0, write 0 amp meters, amp meter. So once you have this written, now the switch is now closed. Calculate the equivalent resistance of the circuit. So now they want the equivalent resistance of the circuit. They're not saying calculate for the parallel, they want the entire thing. So for us to be able to calculate the entire thing, let's start off with the R parallel. So this is R parallel here. So for R parallel, if you look and you check your formula sheet, you will find that the formula goes something like this: R1 plus 1 over R2. So this is basically the formula. So we know our R1 and R2. So now we are quickly going to substitute the information accordingly. So now that we know that this is 8 plus 1 over 8. Now from this point it becomes easy, because clearly this 2 here makes up 2 over 8 if you use the lowest common denominator, and you still have, this was supposed to be 1 over RP, right? 1 over RP, so you still have 1 over RP this side. You therefore cross multiply at this point, so you have your 2 RP is equals to 8, and then you divide by 2. RP is therefore equals to 4 ohms, right? You are not done, however, because you are calculating the equivalent resistance for the entire thing. So you'll have then your R total, where you will go R parallel plus R in series RS, which will give you R parallel is 4, RS is 8 plus 8, therefore R total is equals to 12 ohms, right? Once you are at 12 ohms, you know that, okay, you need to calculate the reading on volt 2 now. Now the reading on volt 2, where is our volt 2? There is our volt 2. So to get a reading on volt 2, we simply have to go V2 is equals to, now if you look at it, there's a trick behind it. So V2 is equals to, now we have a volt reading there, or let's just go V is equals to current times resistance. So for volt we have 24 equals to, for our current we do not have the current, so the volt that is flowing through, so we'll still have the I. The resistance, we'll take the total resistance, and we then know that I will therefore be equals to, I will be equals to 2. Yeah, 2 amps, right? So at this point